I'll take you through the geology of this particular area. Basically, what I would like you to understand is, in terms of diamond formation, the only type of rocks that are responsible for bringing diamond to the surface are called lamborite or kimberlite pipes. But however, the type of deposit that we are mining here in Chiadzwa is a different type of deposit. This is an alluvial diamond deposit. Right? And then in terms of the geological language, this area will refer to it as the Umkono Basin, which is about 1.1 minus million years old. So the diamonds that are here, they were formed as a result of weathering and transportation from different kimberlite pipes, which we are not aware of in terms of their source. But they were deposited within this Umkono Basin, which is more of a folded basin. And present day, maybe for the people of us to easily understand or appreciate what I'm trying to say, I would like you to liken this to more of an ocean. So there were different rivers, right? There were different streams that were eroding diamonds from various areas. The source could be continental. Up to now, we do not know the source of the Chiadzwa diamonds. So the diamonds were deposited from this big folded Umkono Basin, which takes us all the way from Chiadzwa, all the way even up to Chimanimani and part of Chimanimani. So at the bottom of this Umkono Basin was what we refer to as the basement granite. And then on top of that, they got a layer which is referred to as the conglomerate layer. So the conglomerate is the one which hosts our diamond. It is a glass supported unit which consists of rounded to sub-rounded glass, mainly of quartz material. And they are bound together by some fine grained matrix, which we're able to make the fluid more consolidated. And that's where our diamonds are sitting on. So this is a massive deposit, and it is world class in its nature. So where we are here, the deposit stretches for plus or minus 5 kilometers from north to south, and it is dipping almost to the east at a shallow angle, as you are seeing from that pit, at a shallow angle of plus or minus 10 degrees. So the thickness of the conglomerate layer, it's about plus or minus 1 meter. That's where our diamonds are hosted. And above that conglomerate layer, we have got what we refer to as a grit. The grit has got fine-grained particles, and you also tend to find some small diamonds within this grit unit as well. So this Umkono Basin, it is comprising of more of a fining up sequence, where you've got some coarse clast at the bottom of the basin. You get into the grit, and as you go up the sequence, you tend to experience some finer grained units. But the finer grained units are barren, they don't consist any diamonds. So all our efforts, as you are seeing right now, they are concentrated within the conglomerate units. So part of the conglomerate units are exposed to the surface, but right now, as you are seeing the high faces there, the greater part of it is need to be stripping to be done for us to expose that conglomerate unit. So in terms of grades, the grades are out of this world. The grades are as high as sometimes you tend to get grades which are above 1000 CPHT. That is carats per 100 tons. And then maybe for comparison purposes, most kimberlite pipes have got grades which are ranging maybe around maybe 8 or so CPHT. So for this deposit, we've got grades which can go up to 1000 CPHT. However, what I would like you to understand is this is more of a low grade deposit. The gem content is quite low, 8 plus or minus 20%. And then the greater part of the units are more what we refer to as industrial diamonds, or what we refer to as deposits, which are low-grade deposits. But in terms of the concentration of diamonds, this is a massive deposit. I think this is what I can say for now. I think we are now super geologists. Thank you. Are there any questions? Like I said, the road type that most of the diamond is what we refer to as the conglomerate, which is a competent rock. And above the conglomerate, there is a grit. And above the grit, I've got a rock which is more fragmented. These other sedimentary rocks or sedimentary units. So above the grade, the rock is not accommodated. It's a consolidated rock, yes, but in terms of geotechnical characteristics of that particular rock, it is a weak rock. So there are other people trying to look at the possibility of us doing underground mining, but with this type of rock now, it's difficult for us to go underground. We have to do what we refer to as a massive open cast pit, because the rock is not competent at all to support underground operations. We've done a lot of exploration in terms of drilling for these particular units. The deepest part of this conglomerate is sitting at plus or minus 300 meters from the surface. And the 5 kilometers which I've talked about, it is only part of the ZCDC concession, which is tracking north-south. But there are other areas which have not even touched. And there are also areas which are being mined by other guys, like we've got the engine. We've got also more exploration target areas again, which are still to be explored. So the potential in terms of the resource is quite high. So if you have to look at our resource statement, you'll find that we are sitting at more than 50 million carats of diamonds in this particular concession. But there is always some categorization which is to be done in terms of geoscientific knowledge and confidence, which is supported by the amount of work that would have been done in us to ascertain which category should we put that unit into. But it's a massive unit. We have mined it at plus or minus 50 meters from surface at the moment. So we are still to cover all the way up to about maybe 100, 200 meters from surface. It's a matter of, there are a lot of parameters that have to be involved. Your stripping ratios. Are you making profit when you're mining at 200 meters from surface? I think the engineer will talk about that as well. The Chikwarikwari pit. We have got 3 main pits. We've got the Shamarai pit. This area is Chikwarikwari. And the other one, which is further to the south, is what we refer to as the RBZ. Why we call it the RBZ? Because the grades there are phenomenal. They are very high grade from that particular area in the RBZ section.
1 carat is like 0.2 of a gram. That's the measurement that's used to quantify diamonds. And when we say gem, near gem, hot or industrial, what are we talking about? To classify diamonds, there are what they call 4 C's. Size, that's carat. Clarity, cut, how can you cut it? And then the C is for color. Yeah, definitely color. In terms of minimum transition minerals which give the diamonds the color. So those are what the guys like one of evaluation at NMCs, they look at those 4 C's. Color, clarity, cut, and carat, which is the size. So I think it's very important. So when he says, as a unit of grade measurement for mine planning purposes and recovery, carats per 100 tons, you heard what he said. 100 tons, when you mine 100 tons, how many carats are you able to recover from that? So it's a very important unit of measurement that we use. So the mining process and the process, and the recovery. So I think it's very important. By the way, like I said, I'm also a geologist. When you look, remember our mining engineer, Mr. Kadonda, Gomo Ibapa, Gomo Indabo. You can imagine Gomo Ide, I just get some Kuno. But what if this was not there. We actually want to mine this area. The same 5 kilometers, 2 kilometers going in that direction. Yeah. So when you look at you can see Makala Kasana and Didi. Dolerite is the stone that we need to be grateful for. That's why we are here. Because that dolerite Mukondo stratigraphy is the one that preserved this stratigraphy. Yakavara, kuti tisaerode away over the billionaires. If it were not for that dollar right here, all of this would have been gone, washed away to Save and drained into Mozambique. Probably Mozambicans would be enjoying these diamonds. So, Muchiba Papa, Rosana, Kamka da Grey Chago, and ya Madstone, Istatigraph. This is about Madstone, Queen, European near Dot Limestone. Mchibaba afonyende amuzaswa pane iyo yakati mabandi iyo ndizo baba limestone menyu mwopinda muneme yadoti acos yakata pinkish anditika mchizo baba pane yakata pinkish iyoyo nozopinda pane imwe inonzi grit yakada ngejecha ido type edombo iroro anditika but grit it also contains my diamonds. Then beneath the grit amona pane chimshini chikuza dust icho pane vari kuti vari pava amona pingi iri kubuda iyo. That's the conglomerate that we are all here for. That is the unit hosta madiamonds atiri kuda saka all zviri kuservisa izvozvo zvofanira kubva. That's why vakadaonda vakatanga kunyatsanangura kuti zvezvinoitiwa kuti tigone kuda izvozvo and involved so that as a business we're able to mine and recover in the blast 80%. Let me hand over to our mining engineer.
My name is Tawanda Kadonda. I'm the mining manager, also in charge of mine planning. So Mr. Mvura and Mr. Mangoma, they've explained the general exploration site. So what they've told us is this whole area of Chiadzwa, we have drilled in terms of exploration, and we have defined the resources in terms of how many tons do we have and how many carats. He spoke of 50 million carats. So our role as mine planning is to really define, are we able to mine everything at profit? Is everything economic or not? What factors do we consider? We consider our cost of mining or our cost per carat. We also consider the grade that they have sampled, because they do bulk samples. They determine how many carats are in a ton. That's the carats per 100 ton that they were talking about. Then we also look into the diamond price. As we know, we have got a strategy to say we are supposed to add value, because it's also important in terms of how much are we going to utilize our resources. So the diamond price is also important. So we do what we call pit optimization. We use mine planning software. Here we use W2 mine planning software. We use SEPAC. We also use mine scheduling and Falcon. These are the softwares that we input all our cost information, our financials, and also our physicals. There was one question about what are the challenges that we face in terms of the rock characteristics. So generally what we want to establish, how further can we push our slopes so that we will not end up having a collapsed mine. So we also take into the physical characteristics of the rock when we are determining our open pit optimization. So that process we have done. This whole area of Portal A in Chiadzwa, we are going to do what we call a super pit. So we have defined 12 million tons, that is 50 million carats. We are going to mine everything using open pit mining. So how do we develop our pits? We mine them in benches. From the top, we define 10-meter bench heights. So the furthest that we are going to mine in this pit is 100 meters. So we are going to have 10 benches from the top. You do a 10-meter cut, then you step inside what we call a bench. Then we go down the terraces, like the stadium terraces. They also maintain that stability. As you can see, there are also terraces on the side. So that is the optimization. The total waste that is contained in this pit, and we schedule them annually, then we define our life of mine. From that, we know how many cars we are going to get another. We also know how much waste we are going to use. Then we can plan our equipment. How many extra vehicles that we need to mine. That is the general planning side of it. We also inform that into the capex model and financials. Then we submit to the finance team. The finance team will actually develop a schedule, a financial schedule. Us as ZCDC also including the national budget, our submissions are going to generate this large in terms of carats. We have it to get. So you see that is involved as well. So from the mine planning perspective, we've defined our plans, we've done our schedules, we've submitted to the finance team. They've told us we are in business, we can make a profit because it is going to include all the other value chain processes and costs. So that model will tell us we are here for plus 12 years and we are going to mine a profit. And then all the value additions are catered for by MMCZ together with the marketing department. So this is generally how we define it. Then we come to the actual production that we do. So as Mr. Mangoma was explaining, the top part where you see the brownish part is mostly free dig, what we call topsoil. This we can mine without drilling and blasting. This topsoil is also important for us because it also contains grasses and also trees that we also use for land reclamation, like one of us was asking. So we stockpile that top part, we call it a topsoil bank. So we remove the loose material, then we reach hard ground. We mark the area in a pattern according to the drills. So we remove the top parts using a dozer, scrape. Where you see those purple drill rings, that is the drilling process. The rock is one unit. We cannot handle it in this state, so we have to break it to sizable pieces that we can handle. So we are doing waste stripping as we go down. We come from the top as we mine the benches to reach to the top of all. We drill, so that is drilling currently going on. We are drilling holes. We will put explosives, what we call the process of charging. If you see further, there's that silver truck with the white hose, that's a charging truck. So we are putting explosives into a hole, into holes that were drilled, then we will blast. After blasting, you will see where that excavator is in tracks. We've got 2 excavators there. That is now the loading and hauling process that is happening. So we've started from land clearance. We've done drilling. We will do charging and blasting to fragment the rock. West, we will take it to the west dump. So these are the dams that we have here in Chimanimani North. So what we do is we do what we call in-pit dumping. We want to manage that cost because it is a bearing on our bottom line. So as you can see, that excavator with that truck, it's less than 50 meters. We are doing what we call in-pit dumping, cost optimization. Then if we do not have space, we also have further dams further to the north. So generally, this is the process that we have. So when we have stripped the waste, we will go to the ore bench where those are that small rig is close to that water pool. That is now our ore bench. So we've done all the waste stripping. We are now at our conglomerate, top of ore. We drill and we blast. This is the ore that we deliver to the process plants. So in terms of other ancillary work that we do, we of course encounter water. You can see the pipes. There's a pump there. We do pump water. This water is recycled. It's used for gas suppression. It's also used in the processing plants. We in-pit dumping. After in-pit dumping, we take our topsoil, then we cover. As you can see, other dumps behind us, you can see actually grass starting to grow. We also we have got a plantation of trees that we do testing, then we do plant trees. We are creating a hole, but we are also covering. So generally, this is what we have and what we do in mine planning and mining production. We started the mining in 2017. That's when we started conglomerate mining. So generally, to put you into perspective, where those 2 cars are parked, that's where we had an outcrop. So we are starting from that point, and our ore body is dipping southeast at a 5-degree angle. So we've moved from that part to here in it's generally 6 years. So we do have further 1.5 kilometers going to this direction. So this is just over 6 years. This has been our footprint. Really, just under 400 meters in six years. But the strike, like I'm saying, 6 kilometers. So we are here. Most of you wonder what is still happening in Chiadzwa. We are now mining conglomerates, and we do have abundant resources in this area. Anyway, from that point, we've been mining the ore seams. So we are advancing. We are taking cuts. Every year we do what we call pushbacks. So in terms of equipment complement, excavators, we do have, we had 9. We received last week 2 brand new excavators, 976 linear machines. So we now have 11 excavators. Then trucks, we've got 21 trucks. And drill rigs, we have 5 drill rigs. It's a highly mechanized operation, as you can see.
Alluvial resource is partial. It covers a lot of area. I think the conglomerate footprint should be maybe about 500-600 hectares covered by the conglomerate. But so far in the 5 years, I think we've only mined 4-5 hectares or so in 6 years. So you can actually do a simple proportion to actually come up with the life of the mine. So we are pretty much here. Amupa patikuona pane marigs apa. Pasi kunosvika kuboundary ye special grant inoi pane 1.5 to 1.7 kilometers dzatofanira kudzika tichienda west chingoita setichisa site chichitora conglomerate tichiendesa kuplant. So there's still quite a lot of work that we need to do. But like what Mr. Donda said, as we go down, keeping cost or amount of waste that will be engage under, which entails that we need to bring more trucks or to get more contractors to actually help us to really remove all that waste so that we get to the conglomerate. The target, everything that we do is to get the conglomerate so that we give our plan manager the material to process. Are there any other questions?
Welcome to where we use density separation technology as well as the X-ray factor technology, which is called XRT technology. After the XRT technology, we then take the concentrate that we obtain from those 2 processes to the half boxes, where hand picking is done by trained hand sorters who are able to identify different diamonds and sort them into different categories. We basically sort them into gems, into non-gems, and into bots, and also we screen them into different sizes before we send them off to Harare for further sorting and evaluation and marketing of our diamonds. So basically, in a nutshell, that is what we do here within the processing.